this video we're going to talk about quadratic functions. Quadratic functions are we're talking about functions where your highest power is the second power. The parabolas that we talked about in previous lessons, those are quadratic functions. Any function that can be written in the form f of x equals ax squared, notice that's your highest power is x squared, plus bx plus c. And this is standard form of a quadratic equation we saw when we talked about the quadratic formula. Same form, where a, b, and c are real numbers and a is not equal to 0, so your leading coefficient has to be there. The graph of any quadratic function is called a parabola. If a parabola opens upward, we say that its vertex is a minimum value. That's the lowest point on the function. There's always an axis of symmetry in a parabola. The left side matches the right, especially on a quadratic function. Remember, it has to pass the vertical line test to be a function first and foremost. So you have a vertical axis of symmetry. The vertex for a parabola that's opened upside down would have a maximum value of the parabola. The basic curve we've talked about in previous chapters, y equals x squared. You know the vertex is at the origin. It's opened upward. You know the different points on the parabola that you can use as guidelines. So applying graphing techniques to a quadratic function, if we have a function that has x minus h squared, in this case, a horizontal shift. If it's minus h, we know we're going to shift to the right. If it's x plus, then we know we're going to shift to the left, opposite of what you would think. If we have a number added or subtracted, that's going to shift us vertically either up or down, depending on the sign. And if you have a number in front, a coefficient in front of your x squared, you know that if it's positive, your parabola is going to open upward. If it's negative, you're going to open downward. And if this is a number like a number greater than 1, it's going to make our parabola open more narrowly. Whereas if this is a fractional value, some value between 0 and 1, like 1/2 or 1/3, we know that it's going to make the parabola wider than normal. So let's practice that on graphing some of these parabolas with the translations already involved. In this one, negative x squared minus 4, you already know that that's going to be the upside down parabola. So let's just sketch that as a kind of a guide. I'm going to sketch the upside down parabola there because of the minus sign. We know the vertex is still at the origin. 1, negative 1, negative 1, negative 1. 2, negative 4, negative 2, negative 4. So this is your basic curve flipped because of the negative x squared. So that's going to flip it across the x-axis. Now, the minus 4 being subtracted here from the function lets me know I'm going to do a vertical shift. In other words, we're going to shift everything down 4 units. So all those points are going to move down 4. So my vertex is going to move down 4. The 2 points, 1, negative 1, negative 1, negative 1, negative 1, that's going to shift down 4 units as well. So here is my actual new graph. This is the actual function, negative x squared minus 4, right here. So let's erase your guideline graph here. We don't need that. So that's what we're looking for. F of x equals the quantity x plus 1 squared minus 3. Now in this one, we don't have a coefficient in front at all, so we're going to have just a normally opened parabola, opened upward because this is not negative. X plus 1 in parentheses, so it's going to shift it to the left 1 unit. And then the minus 3 being subtracted from the entire equation is going to shift us down 3 units. So to get a baseline, let's draw the basic curve out. The basic curve we know goes through 2, 4, negative 2, 4. So that's just what the basic curve looks like. Now if I shift it around the points like this, each point to the left 1 and down 3. So to the left 1, down 3. The vertex to the left 1, down 3. Okay, so this is actually what my graph is going to look like. So we can take the blue out. We don't need it. There's the function we're looking for right there. Okay. Now if you notice, this parabola is given to us in the standard quadratic form, but it's not in the form where we're used to seeing where the numbers where you can know what the vertical shift or the horizontal shift is, because we're not used to seeing that with that extra x in there. But I can get this in the correct form. It's not in the correct form as we see it, but we can do some work on that algebraically to help us. So I'm going to think about it like this. We have f of x equal to x squared plus 2x. I'm going to just keep that the way it is. Move over to I'm going to move that plus 4 just kind of out of the way. Now let's complete the square inside here, inside the parentheses, like we learned to do earlier in the course. If you take the middle number, take the 2, half of it would be 1, and then 1 squared would be 1. So I'm going to add 1 to complete the square. Now, since this is all occurring on one side of the equal sign, whatever I put into the problem, I have to take back out. So if I put a plus 1 on that right side, to take it back out, I'll take a minus 1 away to balance it. So now my equation actually is, this is factored as x plus 1 squared. Think about that. Two numbers that multiply to give you 1, but add to give you 2. So it'll be x plus 1, x plus 1. And then 4 minus 1 is 3, so plus 3. So now my function is in the shifted form we're used to seeing. So x plus 1 in parentheses square, we know we're going to go to the left 1 unit. And then the plus 3 means we're going to go up 3 units. So I'm going to graph my basic curve to just kind of give me some points to go by. 2, 4, negative 2, 4, negative 1, 1. So here's my basic curve. Again, I keep drawing this curve over and over, but it's just kind of good to have it as a guideline. So each point we're going to shift to the left 1, and then up 3. So I'm going to take the vertex to the left 1, up 3. So there's your new vertex right there. To the left 1, up 3. So here is my new, this is the function we're actually trying to graph there. So let's take the basic curve back out of the problem. Well, I took too much out. Okay, so there's the function you're looking for. So you can use completing the square techniques to get your parabola in the correct form that you want. All right, let's try another one. This one is also in that weird quadratic standard form here. It's not in shifted form. And also I see a number in front of my x squared, which lets me know this is going to be a little different than what we've been working with. So I may have to resort back to like a t-chart or something like that to kind of help me through this. But let's work with the algebra just a little bit to see what we can actually do with it. I have 2x squared plus 12x. I'm going to group that together and then move that 17 kind of out of the way. Now, I can't complete the square if I have a leading coefficient. Maybe you remember that from earlier on in the course. Maybe you forgot it, but I have to factor out the 2. So x squared plus 6x. Now, inside the parentheses, you can complete the square. So take the middle term, half it, and square it. Half of 6 is 3. 3 squared is 9. So I'm going to add a 9 here. Now, I can't just stick numbers in there on that left side, on that right side. So I need to take that back out. So since I put a 9 in that parentheses, it's actually that I put 18 because that parentheses has a multiplier of 2. 2 times 9 is 18. So if I put in 18, I've got to take 18 back out. So I'm going to subtract 18 on that from that side as well. I put 18 in, I took it back out. So the factored form of this equation would be 2 x plus 3 squared, 17 minus 18 would be minus 1. So I know the vertex change here We know that our normal basic curve would be this, the graph of this parabola here. Let's just kind of put it there for a guide. I'll take it right back out in just a second. Okay, we know that we're going to be shifted 3 to the left and then down 1. So let's get our vertex from that shift. So on the vertex, I'm going to take the regular normal vertex of 0, 0. We're going to shift it to the left 3. 1, 2, 3. And then down 1. So my new vertex point is the point -3, -1. Okay, so I'm going to take this back out. There's my vertex. So to kind of get since we're going to have the multiplier of 2 involved here, that's going to make, if you remember, that's going to make my parabola skinnier than normal. So this is very important that I try to get some correct points. So since the vertex is right here at -3, -1, we know the axis of symmetry will run right through it. So let's pick some points to the left and right of it. I'm going to pick the -2 and the -1. Plug those in and see what we get. If I plugged in -2 here, that'd be 2 times 4, which is 8. 8 minus 24 plus 17 equals 1. So -2, 1 is going to be a point on my graph. So I know symmetry says that I'll have 1 here as well. All right, and if I plug in -1, that's going to give me 2 minus 12 plus 17 okay, so I got +7, -1, 7. This will be up here. And so symmetry says I'll have another point right there. So here's my graph here. It's a little thinner or skinnier than a normal parabola would be. If nothing else, though, the shifting and stuff here gives you your vertex point. Let's try one more. This one, since my leading coefficient is a negative, I know that it's going to open downward. We do know that just by looking at the equation. But this, again, is still not in what we consider shifted form for us. So let's get it that way, the way we want it. So f of x equals, I am going to put the negative out front. So that's going to be x squared plus 2x if I factor the negative out. And we're just going to scooch the +1 out of the way. And to complete the square inside, I could take half of 2 as 1. 1 squared is 1. So I've actually put in a -1, so I need to put another +1 to balance that. Because of the negative outside, when I put the 1 in, that created a -1. To counteract that, I had to put +1 over on the right side here. So this in factored form will be negative x plus 1 squared plus 2. So we've got 3 things going on here in this problem. We know it's going to be flipped. X plus 1 in parentheses means we're going to shift to the left 1 unit. And then the +2 means we're going to go up 2 units. So the normal upside down parabola basic curve would look like so. -2, -4, 2, -4. That's the normal one. But you're going to take those points and we're going to shift those 1 unit to the left, then up 2. So left 1, up 2. There's my new vertex right there. Left 1, up 2. So this is my actual graph that I'm looking for. I'm going to take the basic curve out so we don't see it.